This is Lab 12, we're Lab Group 6B. I'm Ridley.
I'm Cameron.
And I'm Daniel.
The objective of this lab was to have fun.
The unique anatomy of the eye tells us that the majority of the reflective power from the eye comes from the cornea. The eye lens is mainly used for accommodation, giving us the ability to focus on things at variable distances. The eye is sensitive to light in a couple of ways. Using cells called rods and cones, the retina is able to detect light. With close to 125 million rods used for monochromatic light sensitivity, we're able to detect the presence of light. And with small, approximately 6.5 billion cones, the eye is able to detect color sensitive to 3 separate colors, specifically red, green, and blue. An important thing to note is that the max density of cones is located where there are almost no rods.
Not all eyes are born equal. Your brain prefers one eye for processing visual input. There is a quick trick to determine which eye is the dominant eye. This is done by cutting a 20mm hole into a piece of paper and staring through it. Close one eye at a time, and the eye where the image does not shift is the dominant eye. The hand hole eye experiment allows you to see a hole in your hand. This is because eyes create 2 separate images and your brain stitches them together.
There is a small portion of your visual field where there are no rods or cones. Therefore, there is no image formed at this position. When both eyes are open, the blind spots are no longer there because the 2 visual fields overlap and cancel out the blind spots. The way we tested our blind spot in lab was with a paper that had a dot and an X on it. By covering up one eye, we stared at a dot on the center of the page. 8 centimeters over from the dot was an X. The paper was moved closer and closer to our face until the X disappeared. The distance was measured and the results for each team member's eyes are shown below. We then came up with a way to test the binocular field of view of our eyes. Daniel stared at the optical table and Cameron stood behind him with her arms spread out. She brought her arms towards him until he could see her hands. From this, we were able to measure and calculate the binocular and monocular field of view. The binocular field of view is the region simultaneously visible to both eyes. Daniel's binocular field of view was approximately 110 degrees. The typical value for this is about 114 degrees when the eyes converge symmetrically. Monocular field of view is the region visible by each eye. He measured the monocular field of view for the right eye was 64 degrees and for the left eye was 61 degrees, giving an instantaneous monocular field of view of 125 degrees.
The visual acuity of the eye can be measured by the use of the Snellen eye chart. The descending rows of the printed letters decrease in size. The performance on the eye is characterized by the smallest row that is readable at a 20-foot distance away from the Snellen chart. The visual acuity from this chart is defined as S is equal to D prime divided by D, where D prime is the standard viewing distance from the chart and D is the distance from which the object should be viewable. This ratio defines the acuity of the eye, and the assistance of glasses and contacts can improve someone's visual acuity. Cameron's eyes were not good without the glasses, but much better with the glasses on. Ridley, who's wearing contacts, had good vision. Daniel did not wear contacts or glasses and could read 20/20, so clearly he has the most superior eyes.
Contrast sensitivity is a measure of the limit of visibility for low contrast images. This means how washed out an image can become before there is no longer a distinction between high and low contrast images and everything appears to be a uniform field. Contrast sensitivity is measured in terms of the ability to separate sine wave grading patterns with varying spatial frequencies and varying contrast. Functional acuity contrast test did not work on any of our browsers, so we weren't able to do it. Flicker fusion frequency is the frequency at which a source light can be modulated such that the flicker of the light isn't perceivable to the human eye. In lab, the red LED was being modulated by a square wave function generator at frequencies between 25 Hz and 75 Hz. In the direct test, we looked at the LED. The frequency of the function generator was slowly increased until the LED appeared to be continuously emitting light without flickering. By testing this using the peripheral vision to see flickering, the results indicated that flickering lights are easier to detect in the periphery. Our results also seem to indicate that in general, the brain is less sensitive to the flickers of the red light, and the green LED seemed to persist in the flicker phase at higher frequencies when compared to the red LED.
Color vision is the ability for a person to perceive objects based on wavelength. The monochromator takes a white light source and separates it into its wavelength. We scrolled through the visible wavelength range and determined what wavelengths we were able to observe in lab. This test consists of a number of colored plates with circle and dots appearing in randomized color and size. The plates are used to determine if someone has a color vision defect and to what severity. Everyone in our group were able to correctly identify the numbers.
A stereogram is a single image used to create a visual illusion of a 3D scene. They are repeated horizontal colorful images. Each eye sees the image from a different perspective, and your brain then combines them into slightly different views and creates an image with 3D depth known as stereopsis. The next solution was the photogenesis illusion. With the microscopic rods and cones in our eyes, the codes become overworked when you force your eyes to stare at the same image. So when you look away from the image, the tattered cones can't tell your brain that the image is new, and your brain interprets the old information since it hasn't received a strong enough fresh signal. The effect wears off shortly. This is watching you.
Here are other optical illusions we found interesting.